Hey everyone, let's discuss these questions one by one. First one, what is the end product? You see, first A would be Grignard's reagent. We'll get this as minus MgCl plus. And then it is being treated with aldehyde, formaldehyde, which will attack here, make this as CH2O minus MgX plus, which on hydrolysis will give us this alcohol. So that is option 2. Here everybody. Second, we need to check out the reaction diagram. Check out first, in the presence of water, it is a tertiary position. So it will form a carbocation. This is step 1, which is the rate determining step. RD is rate determining step. Then the second step would be H2O attacking here, which makes it OH2 plus nucleophile attacking there. Next, the third step would be removal of proton. Thus, we will get this as OH. So if you notice that this is intermediate 1, this is intermediate 2. This is intermediate 2. So we need to have 2 intermediate state and 3 transition states, because you can see this is one arrow. Arrow 1 means 1 transition state, 2 transition state and 3 transition state. And overall reaction is exothermic because it is substitution. It has to go through exothermic. So you can see that this option is matching. Reactant has less energy than product. Sorry, more energy than product. So this is exothermic. There are 3 transition states and there are 2 intermediates. So therefore, the second one is a better option for that. I hope all of you got that. See the next question, 33. Addition of Ki accelerates the hydrolysis of primary alkyl halides. See, primary alkyl halides like chlorine, if you treat that with I minus, iodine is a good nucleophile, so it will substitute there, and then water will be able to replace this iodine more easily because iodine is a good leaving group. So reason for presence of iodine will help is it is being a powerful nucleophile also in water, as well as it is a good leaving group also. So that option is better matched with 4. Next, you can see this side of the reaction here. This is going towards, the rate is increasing as you go towards more substitution, which means this is more signifying SN1 type of mechanism. If you notice this side here, the rate is very high for primary or 1 degree. So this signifies SN2 type of mechanism. So A is for SN1, B is for SN2. Done. Next, butanol here, that is Cl here and OH here. When you treat this with OH minus will first extract proton and then make this as O minus, and this O minus will attack here, removing away this chloride. That way, I will get a 5-membered ring, which is this one. Okay. Next, 36. Which of the following will make NaCN faster reaction? For SN2, methyl is going to make a faster reaction than 1 degree, 2 degree, 3 degree. So you can see first one is 3 degree, so no SN2. This is secondary, this is primary, and this is primary as well. And if you notice the leaving group ability, OTS is very, very strong. Okay, OTS, TSO. Okay, OTS is very, very strong leaving group compared to OMe. That makes 4 to be the better reaction for SN2. Check out 37. Here, nitrogen will have delta positive, chlorine will have delta negative. Delta positive, delta, sorry, delta negative and delta positive. Okay. So phenyl will attack here, removing the chlorine. Attacks here, removing this chlorine. Okay. So A would match with Q, B would match with P. Next, here phenyl is attacking on this carbon, removing chlorine. That makes it ketone, which is S. And here, this will attack here, removing here. That will also become a ketone, which is R. So QPRS, QPSR, sorry, that will be 1. Which combination of reagents will bring the following conversion? So let us see this. First, I have a keto group here. If I treat that with MEMGI, I would first get an adduct of O minus MgI plus, right, with a methyl group on it. That on hydrolysis will make it OH. And that if you treat with H2SO4 and heat, elimination will happen, giving this double bond. That when you treat with HBr in the presence of peroxide, anti-Markovnikov's addition will take place, which results in formation of this Br. Done. Notice it, everybody. So this is the product which we are expecting. So which is the best reagent here? First one. Next one. Which of the following undergoes Walden's inversion? For Walden's inversion to happen, it should have a chiral center. First one does not have a chiral center. Second one does not have. Third one has chiral center. Fourth one does not have any chiral center. So answer was very simple here. It was based on a chiral center. Nucleophilicity order in the polar solvents is this one. Okay. If you recall, polar protic solvents, down the group nucleophilicity will increase. That is I minus greater than Br minus greater than Cl minus greater than F minus. So first statement is incorrect. Due to bigger size, I minus is less solvated, which is true. I minus is less solvated. That is the reason why it has strong nucleophilic nature. So first one is false, second one is correct. Next one. Aqueous KOH. Well, this is secondary position with little bulkiness on it. So it is difficult for it to make SN2 completely. SN2 will be of a very small amount. Rather, whenever there is a secondary compounds, we will always expect SN1 also, which means first carbocation will form. This carbocation will make a ring expansion, which will make this as positive charge here. And again, that carbocation will rearrange to this position on which OH minus is been attacked. So we will get this tertiary alcohol, which is option 3. Laid out.
Sir,
Yes.
sir, how
Yes,
to
beta.
know whether ring expansion will happen or
How to know whether
ring expansion will occur or not?
ring expansion is subject to 4 member converting into 5, 5 converting into 6. 6 to 7 won't happen. 3 to 4 very rare case, but usually don't happen. Okay. So you should always look out for these two options, 4 to 5 and 5 to 6. Got it?
Yes.
Next. There is a 3-membered carbon with iodide. Now that could be primary or secondary, does not make any difference. If there is an iodide here, you're treating with alcoholic KOH, that makes it alkene. When you treat that with NBS, it is an allylic substitution. So allylic substitution will take place. Then Cn minus will make an SN2 mechanism, removes out this bromide. So thereby we'll get this as cyanide. So which is option 2. Check it out. Even the iodide may be at the secondary position or primary position. It does not impact the reaction. Still be same. 43. Boiling point will always be directly inversely proportional to branching of chains. More the branches, less will be the boiling point. Therefore, 1 will have more compared to that of 2, which is almost same as 3 and greater than that of 4. So highest boiling point will have for 1 because it has no branching. Next, C3H6Clbr. Now there are 3 carbons here. So you can see 3 carbons with bromide and chloride here. Next, keeping bromide here, I can keep moving chloride. So this is the position. Or keeping chloride here, I can move bromide. And finally, I can have Br and Cl at the center. These are 5 structural isomers I can draw. And if you see, this is a chiral center. This is a chiral center. This is a chiral center. Okay. So which means out of these 5 structures, there are 3 chiral molecules which are optically active. So this is second one. Clear? Next, 45. Free radical chlorination of N-butane gives 72% 2-chlorobutane and 28% chlorobutane. You notice this one. Here we have, I'll write 45 here. Check out. This is butane. Butane has, 1 degree alpha hydrogens, has 6, 2 degree alpha hydrogens as 4. And the rate ratio, if you rate of chlorine ratio is, when it comes to 1 degree, 2 degree and 3 degree, is 1 is to 3.8 is to 5. So if you want to get percentage amount of 1 degree chloride, 1 degree Cl, okay, which is like this chloride here, this one, then it has to be, 1 into 6 divided by 1 into 6 plus 4 into 3.8. If you want 2 degree, right, 2 degree chloride, which is like this, and that will be equal to 4 into 3.8 divided by 1 into 6 plus 4 into 3.8. This into 100, this into 100. This is coming out to be around 27%, and this is coming out to be close to 73%. Okay, so which means the option is correct. 72% of 2-chloro and 28%. Well, this is 72 and 28 to be precise. Yeah. So first one is true. First one is correct. Second statement is a secondary hydrogen is substituted more easily than primary. Well, because the secondary hydride is better, more stable radical as compared to 1 degree radical. Okay. So therefore, we can say that, both the explanations are correct here. So reason and assertion are okay. Done. Next. SN2 reaction of CH3 MgBr is faster in DMSO than H2O, which is incorrect. So because SN2 reactions are more favorable in polar aprotic solvent, okay, and less favorable in polar protic solvent. So first statement is incorrect. DMSO has, faster is said, no? So then it is correct only. So statement is correct. that it is faster at DMSO than water. DMSO has greater capability to solvate nucleophile. Incorrect, because DMSO is like this: O, double bond S, and this one. This is double bond O, S, and like this. Double bond O, S, and like this. So which will have delta, delta negative, delta negative, and delta negative. Suppose if my nucleophile is CH3O minus Na plus, this is nucleophile. So it is the Na plus which is getting solvated. You can see Na plus will strongly get attracted by these oxygen molecules here. So basically Na plus is being completely stopped by these DMSO ions, while CH3O minus moves very freely. So therefore it is not solvating nucleophile, it is solvating the counter ion of the nucleophile. So first statement is true, second one is false. High concentration of nucleophile on the secondary alkyl, like this, if you have chloride, and I increase I minus concentration or ACO minus concentration or N3 minus, these are all very, very good nucleophiles or strong nucleophiles. So that will convert into this nucleophile. So first statement is correct. True. Second statement, secondary alcohols when you treat with large amount of ethanol, so chloride with ethanol, ETOH, definitely we can expect this to become OET, but this is via SN1 mechanism. So this is also true. So both the statements are true here. So this one is correct. Clear? Check out 48. When you treat Cl2 with HNu, it is substitution reaction and more stable position is allyl position. So chlorine will get substituted here. When you treat in the presence of CCl4, it is an addition reaction. So electrophilic addition. So this is electrophilic addition. And here it is radical substitution. Then best options matched here are 3. In the given rate, if you recall SN2 type of mechanism, 1 degree, sorry, when it comes to benzyl, CH2X benzyl greater than CH3X greater than allyl, like this, allyl halogen greater than 1 degree, CH3CH2X greater than 2 degree, greater than 2 degree, greater than 3 degree, and so on. So you can see that allyl is always greater than that of 2 degree, 3 degree, and vinyl. Vinyl is extremely poor. And within the groups, if you have Ri, that is more reactive than RBr and RCl and RF. So therefore, I can say this one, Br is most reactive, then Cl, then we have secondary, and then we have this vinyl. So it is BCAD. Okay, so which is third one. 2,3-dibromo, 1-phenyl pentane. Okay. So first we need to check out that it is 1, 2, 3, 4, 5 pentane. On one position, you can see there is phenyl. On 2 and 3 positions, we have dibromo. So this one is more appropriate. Next. Check out 51. Number of isomeric products formed by monochlorination of 1-methyl cyclohexane. This is the one with Cl2, monochlorination. So I can get 1 chlorine here. Okay, let me copy these structures. Okay. First, I can get a chlorine here. I can get chlorine here. I can get chlorine here. I can get chlorine here, and I can get chlorine here. These are the possible structural isomers which I can get. In the first case, there is no chiral center, I'll count it as 1. Second case, no chiral center, I'll count it as 1. Third case, I have 2 chiral centers, so 4 stereoisomers I can get. Here also there are 2 chiral centers, so 4. Here we can have cis trans isomers, so another 2. So total how many? 12. Clear? So question asked was total number of products. So that is going to be 12. Next. 52. This is NaOH in C2H5OH. This is like an alcoholic, KOH or NaOH. Alcoholic KOH usually give you elimination product. So which will give you this as CH2 via E2. And water will give you substitution product, which is CH3CH2 and OH. So number of hydrogens here are 6. Number of hydrogens here are 4. So which makes it 10. Next. 3-methyl. Let us see this 53. 3-methyl hex 2-ene. Like this, we have 1, 2, 3, 4, 5, 6. This is 2-ene and 3-methyl. This, when you treat with HBr, we will get in the presence of peroxide. So which means Br should be coming here. If Br comes here, this is one chiral center, this is one chiral center. That makes it 4 compounds here. Okay. So question asked was how many compounds we can get. Next. 54. How many alcohols? Because you will notice that CH3 MgBr will only react with alcohols to extract that proton to convert into CH4. So C4H10O, how many molecules I can have? See, this is one straight chain. Then OH on the second position. Then I can have this isobutyl alcohol. Then we have tert butyl alcohol. So how many such alcohols I could get? 4 such alcohols. Done. 55 SN1. Okay. Rearrangement should happen. You can notice that first Br, if you leave, positive charge will be here. It will come to rearrangement here. So yes, here there is no rearrangement. Here there is a rearrangement because methyl will shift here. Positive charge will move here. Here there is no rearrangement. Here there is a rearrangement. Here there is no rearrangement. Here there is a ring expansion. Ring expansion is also a rearrangement. Here there is no rearrangement. Got it? Because it is already at a tertiary position. Okay. Oh, sorry. Here ring expansion can take place. My mistake. Okay. Positive charge. Again, ring expansion can take place. Here we can have, because positive charge can migrate here, so another ring expansion can take place. I mean, once you get positive charge here, we'll have an allyl position, so resonance can take place. Here resonance is already existing, so no. So how many we get here? So 1, 2, 3, 4, 5, 6. So 6 of them. Clear? Next. Total number of possible products in this case. First, OH in the presence of H plus and heat. We can get 3 alkenes. One is this alkene, the other one is cis, the other one is trans. And if you treat this with Br2, I can get Br here and Br here, which makes one chiral center. So the number of products are 2. If I add Br2, this is cis plus anti-addition. Anti-addition will give you 3O. 3O means Br here and Br here, H and methyl. So 3O optically active, so we will have plus and minus both. So two products. Here, this is trans. Br2 addition is an anti-addition. Trans plus anti will give you erythro. So Br and Br will get added here like this. So this is a mesoform if you notice. So mesoform means it has a superimposable mirror image. So only one should be counted. So number of Y which we take out here is Y is 5 and X here is 3. So total amount is how much? 8. So that is a question asked. So how many possible X plus Y would be? X 57. Which will be greater than 1 bromopropane like this in SN1. So we need to check out more stable carbocation than primary carbocation. First one is vinyl, so not stable. Second one is allyl, so stable. Third one is methyl, unstable. Fourth one is benzyl carbocation, stable. Fifth one is phenyl. Sixth one is anti-aromatic. Seventh one is 3 degree. Eighth one is 2 degree. Ninth one is aromatic carbocation. So how many carbocations we are getting? 5 of them. So 5 carbocations which are more stable than primary. Next, 58. What is the percentage amount of SN2 here? Okay. So you would notice that this rate, this part of the rate is because of SN2 and this part of the rate is because of SN1. And overall rate is SN1 plus SN2. So it is a parallel reaction that Rx is a reactant. It is going SN1 way and it is going SN2 way to give this as product 1 and product 2. Okay. In that case, if you recall, if the rate constant here is K1 and here it is K2, the percentage that is P1 by P2, P1 by P1 plus P2 will be always dependent on K1 by K1 plus K2. We learned this in kinetics. So that is the same thing we need to do here. So the percentage amount of SN2 will be equal to P1, which is 1.67 into 10 raised to power of minus 6 into concentration of base is given as 1, that divided by 1.67 into 10 raised to power of minus 6 plus 0.05 into 10 raised to power of minus 6, which is into 100. So that is 1.67 divided by 1.71, okay, 1.71, right? So that into 100, clear? So that percentage is coming out to is 97%. Done. This is about percentage amount of SN2. Ninth, how many maximum moles of RMGX that will be consumed when you react with compound? We need to check in case of RMGX. First, we need to take acidic hydrogens. If you notice acidic hydrogens where they are, first acidic hydrogen. This is one acidic hydrogen. This is one acidic hydrogen. So there are two acidic hydrogens. Next, we need to check out aldehydes and ketones groups. Check out here one Grignards will be added. At this ketone, we can add one. At ester, we can add 2 times because one will be converting into ketone, second one will convert into alcohol. At acid chloride also, we can add 2 times. Okay, we'll add 2 times here. Correct. So total, now check out how much is the total. 2, we can get this as 2 plus 1, 3, 4, 5, 6, 7, 8. So total 8 moles are required. Total 8 moles are required. I hope all of you understood that. So you can see here acid derivatives usually require 2. So 2 here, 2 here. Aldehydes and ketones require 1 and 1. So 1 here, 1 here. And these are 2 acidic hydrogens. So those 2 require 2. Last. Check out first bromination. We'll get Br here. Then we have minus with MgBr plus. Then we have attachment here. So as an alcohol, we'll get this alcohol. Then we will get carbocation first because H2O is leaving. Then carbocation will get rearranged here. Carbocation will come here. After that, elimination will happen on heating. So this is the product. So this is the final product D. So in this product D, how many pi bonds we have? Only one pi bond we have. So number of pi bonds are 1. None. Everybody are clear with this paper?